Hi everyone, today we're going to study general solution of non-homogeneous differential equation. In this video, we're going to find the particular integral when capital X equals e raised to ax multiplied by the function capital V. The general form of a non-homogeneous linear differential equation with constant coefficients is this equation here. Now, when the right side or when the capital X is equal to e raised to ax multiplied by a function v. Take note that the v here is either sine ax or maybe cosine ax or a polynomial in x. So the equation or the right side of the equation becomes e raised to ax times the capital V. For the general solution, this is y equals complementary function, that is CF, plus the particular integral, which is pi. We learned how to solve for CF. Now for the pi of the function e raised to ax times the function capital V, take note again that the V is equal to sine ax or cosine ax or polynomial in x. This is our formula, 1 over a function with respect to the capital D or the operator multiplied by that function of the right side, that is e raised to ax times the capital V. Next step, we're going to move this e raised to ax on the left side. It becomes like this. And then we evaluate the denominator, the f of d, in terms of the f of capital D plus a. The a value here is the coefficient of x in the exponent of e. Then we copy this capital V function. After that, we're going to evaluate this 1 over the f of d plus a with respect to this function capital V. This is now our formula. Example 1. Solve the equation. Second derivative of y with respect to x minus 7 dy over dx plus 10y equals e raised to 2x multiplied by sine x. And here, the v is the sine x. The general solution, y equals complementary function plus particular integral. Let's begin with finding the CF. Using operators, our equation here becomes the quantity d squared minus 7d plus 10 multiplied by the variable y equals the right hand side e raised to 2x times sine x. The auxiliary equation is m squared minus 7m plus 10 equals 0. So let us solve for m. When we factor out the left side, we have now this m minus 2 times m minus 5, and that is equal to 0. So we equate each factor by 0. So we have m minus 2 equals 0 and m minus 5 equals 0. Solving for m, so m sub 1 equals 2 and m sub 2 equals 5. In here, the values for m are 2 real and distinct roots. So for the CF, we're going to use this formula. We substitute the values of m sub 1 and m sub 2 respectively. So the value of CF would be like this. Let us copy the value of CF somewhere here. Then we proceed to find the pi. So the pi of e raised to 2x times sine x, we have this formula. 1 over the f of d times the e raised to 2x times sine x. We write the value of the f of d, that is, when we use the operator, we have now this d squared minus 7d plus 10. Next is, we're going to rewrite this equation now, this e raised to 2x, we're going to write in the front. So it becomes like this. And then, we will evaluate our denominator with respect to d plus a. For the a, we're going to use the number 2. That is the coefficient of the x in the exponent of e. So we have now, like this, e raised to 2x multiplied by 1 all over. The d squared becomes the quantity d plus 2 is squared. Minus the 7d becomes 7 times the quantity d plus 2. Then we write plus 10. When we expand our denominator, it becomes like this. Let us combine like terms, and the denominator becomes d squared minus 3d. At this point, we're going to solve this 1 over d squared minus 3d with respect to sine x. Remember that we are replacing d squared by the negative of a squared. At this point, the value of a is the coefficient of x in the angle for the sine. And so, the a is equal to 1. So we have here the negative of 1 squared. When we simplify this, it becomes negative 1. So the d squared becomes negative 1. At this point, we're going to multiply and divide the fraction by its conjugate. So the conjugate is the negative 1 plus 3d. Let us multiply 1 by the conjugate. It becomes that negative 1 plus 3d. So in the denominator, we have now this negative 1 that is squared minus the 3d is now squared. And then we will simplify the denominator. For this sine x, we're going to multiply this to the terms of the numerator. So we have now negative sine x plus 3d times sine x in the numerator, all over 1 minus 9d squared. At this point, in the denominator, we're going to replace that d squared by the negative of a squared. Our a is the 1, and when we have this negative 1 squared, we have the negative 1. So we substitute the value in the d squared, it becomes like this. But look at our numerator. This negative sine x will be same, plus the 3 times d sine x means we will take the derivative of sine x. That's why you see here it is showing cosine x. And we simplify our denominator to be positive 10. So this is now the value of our pi. For the final answer, we will simply put the CF plus pi. Our CF is here, plus the value of pi we will just put here. Example 2. Solve the equation, second derivative of y with respect to x minus 4y equals x squared times e raised to 3x. In this example, the function v is this x squared. The general solution is y equals CF plus pi. Let us find the CF. Using operators, we rewrite our equation to be the quantity d squared minus 4 times the variable y equals the right hand side we will just copy. Then we write the auxiliary equation, and that is m squared minus 4 equals 0. Let us solve for m. Let us do factoring. We have m minus 2 times m plus 2. So we have m minus 2 equals 0 and m plus 2 equals 0. So the values of m are m sub 1 equals positive 2, and the m sub 2 equals the negative 2. We can see here that we have two real and distinct roots. Therefore, we're going to use this formula for the CF. Let us substitute the values of m sub 1 and m sub 2 respectively. So the CF now equals c sub 1 times e raised to 2x plus c sub 2 times e raised to negative 2x. Let us copy the CF somewhere here. Then let us solve for the PI. The PI of x squared times e raised to 3x is the formula 1 over the f of capital D times the x squared times e raised to 3x. Let us substitute the value for the f of d. We have this d squared minus 4. Remember, this is the operator for our equation. Next thing to do, we're going to put this e raised to 3x in the front. So it becomes like this. Next is, we're going to evaluate the d squared minus 4 with respect to d plus a. The value of a here is the coefficient of x, which is 3, and that is the exponent for the e. So the denominator here now becomes the quantity d plus 3, that is squared, then minus 4. Let us expand our d plus 3, that is squared. It becomes like this, and when we simplify our denominator, this positive 9 minus 4 becomes plus 5. In this case, we're going to solve this fraction 1 over d squared plus 6d plus 5 with respect to our x squared. So we will use that idea when capital X equals polynomial in x. It means this 5 here is the lowest term for our denominator. We will factor it out and it becomes like this. 5 comes out. The number 1 here means the 5 is divided by itself. Plus, this d squared plus 6d will put us all over the denominator 5. For the terms in the grouping symbol, we're going to put this in the numerator. It means we will use the negative 1 as exponent. So it becomes like this. In this case, we're going to use the binomial expansion. So for the term 1 plus this d squared plus 6d all over 5, that is raised to negative 1, we will show it to be like this. 1 minus the d squared plus 6d all over 5 plus the square of the quantity d squared plus 6d all over 5 minus and so on. But we stop on the power 2 because the x squared here has the degree 2 only. And the next step is we're going to expand the terms inside the grouping symbol here. So we have now 1 minus, in this fraction, we're going to split the numerator. So you see we have d squared over 5 minus 6d over 5 plus, let us expand this expression. But in here, we only write 36 d squared all over 25 corresponding to this 6d over 5. That is squared. We will only copy up to this point because the other terms for this expression would be a degree more than 2. Remember, we only stop when we have same degree with our x squared here. And the next step is this x squared we will multiply to each of the terms of the grouping symbol. So we have x squared minus the d squared multiplied by x squared minus 6d times x squared. We write here. Of course, we have the denominators 5 and 5 respectively. Plus 36 d squared times x squared all over 25. At this point, we're going to simplify this d squared of x squared. It means we will take the second derivative of x squared. This d of x squared means we will take the derivative of x squared. The d squared of x squared, again we say that this is the second derivative of x squared. So the value will be like this. The second derivative of x squared will be 2. The derivative of x squared is 2x, and 2x times 6 we will get 12x. This d squared of x squared means second derivative of x squared, that is 2 multiplied by 36, we get 72. Next thing to do here, this 1/5 we will multiply to each of the terms inside the grouping symbol. So we have like this. We're going to put the terms inside the grouping symbol as one fraction. Let us use the LCD. And to do that, the final answer will be like this. 25x squared minus 60x plus 62 all over 125. And this is multiplied by the e raised to 3x. Remember, this is now our PI, the particular integral. So now we write the final answer. We will just put together the CF plus the PI. So y equals the value of CF we will copy here plus the value of CI is now in here. I hope you learned something from this video. See you again next time.